Okay, so let's look at this example on the back. These look like the examples from our previous set of notes. So we're still going to practice graphing these lines. So we're going to rearrange this to y equals mx plus b. So I'm going to have negative 4y is less than 1. And now to move x to the other side, I'm going to subtract x from both sides. And now I'm going to divide by negative 4 all the way across. I'm going to have y. And now I'm going to ask myself, will my sign flip-flop? And yes, it will, because I'm dividing by negative, so it's going to change to a greater. And then I'm going to have, oh, this should be an 8. So I'm going to have negative 2 plus 1/4, because a negative divided by negative, same sign when your division means your answer is positive, x. Okay, so I want to pick out my slope. My slope is a positive 1/4. So now I need to know, how is that telling me to move for my slope? So positive 1 means up 1, right 4, because I'm always going to write with the bottom number. So I know how to move. Now I need to figure out where's my starting point. And my starting point comes from my b, my y-intercept. So I know I'm starting at a negative 2 on the y-axis. So I'm going to go to 0, negative 2. I'm going to go down to negative 2 on the y-axis. And now I'm going to move up 1, right 4. So I'm going to go up 1, right 4, up 1, right 4, up 1, right 4. I can't fit that point on the coordinate plane, so now I'm going to go back to my starting point, and now I'm going to move the exact opposite. Down 1, left 4, down 1, left 4, down 1, left 4. That's not going to fit. And now I need to figure out, is this going to be a broken or a solid line? And I go back to my symbol. No bar, broken. So I'm going to make my dashes. And remember, it's got to have arrows at the end to show we would have more of a broken line if our coordinate plane was bigger. So now I need to figure out where I'm going to shade. And again, this comes in with your test point. 0, 0 is the easiest test point to use, and I'm going to go ahead and plot my test point. And now it's going to tell me if it's true, I'm going to shade on this side of the broken line where my test point is. If it's false, I'm going to shade on the other side of the broken line. So I'm going to plug in to my original, which means I'm going to use the original symbol. So I've got to plug in 0 minus 4 times the value of 0 is less than 8. So I'm going to plug in 0 for x, and I'm going to plug in 0 for y. And now I'm going to do the math on both sides. So 0 minus 0 is going to be 0 less than 8. And is 0 less than 8 true or false? That is going to be true. And what does a true answer tell me when I plug it in? A true answer tells me that 0, 0 is a solution point, which means in the graph picture, it should be in the shaded area. So I know now to shade on the same side of my broken line as where my solution point is. So all of these ordered pairs in this pink shaded area are going to be included in the solution set. Any point in the non-shaded or outside the shaded area or on the broken line will not count as part of my solution set. Now, if you have a choice between using the graph picture to plot points of your inequality or the inequality itself, which one's faster in figuring out if your solution point is in the solution set? It's quicker to graph it, because based on where it's located, you're going to know if it is or is not a solution point. If you don't have the graph picture to use, you have to plug it in and get true or false. So if I'm going to test the point 5, 1, it's faster if I graph it and plug it in, because I already have the graph picture made. So I'm going to go to where 5, 1 is, and what do you know? It is in the solution set, so it is part of the solution because it's in the shaded area. All right, let's look at the next example. Practicing again graphing. So I'm going to rearrange. 5y is less than or equal to 20. And then to move the 4x to the other side, I have to subtract 4x from both sides. So it's going to be minus 4x. And now I'm going to divide by 5 all the way across. So I'm going to get y. Will my sign flip-flop? And the answer is no. It's going to stay less than or equal to. And now I'm going to figure out my division. I'm going to have 20 divided by 5, which is 4. And then is it going to be plus 4/5 x or minus 4/5 x? And it should be minus 4/5 x. Okay, now I'm going to pick out my slope. It is a negative 4/5. Now I need to know how to move based on those numbers. Negative 4 tells me down 4, and then I'm always going to the right with the bottom number, so it's going to be right 5. And now I want to figure out my y-intercept. So it's the b number, so that would be 4. So I know I'm starting at a positive 4 on the y-intercept. So I'm going to go to positive 4 on the y-intercept, and now I'm going to move using my slope to make my graph line, to make the boundary line. So I'm going to go down 4, 2, 3, 4, right 5, 2, 3, 4. Down 4, right 5, until I run out of space. And then I'm going to go back to my starting point. I'm going to move the exact opposite. So I'm going to go up 4, left 5. Up 4, left 5, which is not going to fit. And now I need to know if I'm making a solid or broken line. So go back to your point. I see a bar, which tells me solid. So now I'm just going to connect my points with a solid line, so there should not be any gaps or spaces. And now I need to figure out which side of my boundary line I am going to shade, which means I need to use a test point, 0, 0. It's the easiest one to use. Go back to the original, which means you use the original symbol. You do not use the flip-flop symbol. So I'm going to say 4, where the x is, put a parentheses, plus 5, where the y is, put a parentheses, less than or equal to 20. And I'm going to plug in my numbers. So x is 0, y is 0, and now I'm going to do the math on both sides. So 0 plus 0 is going to be 0. Is 0 less than or equal to 20? True or false? That would be true, which tells me that where I plotted my test point, that side of the broken line is going to be in the shaded area because it's a solution point. So I know to shade on the side of the broken line where my solution point is. Okay. Now, I want to check 5, 1. Okay, I have two options. I can use my shaded region or I can plug it in. Which one is faster? It's faster to plot your ordered pair at 5, 1 than it is to plug it in and do the math. If you do not have your graph available, your inequality graph available, then you have to plug it in and get true or false. True tells you it's in the shaded area, false is not. So is 5, 1 located in the shaded region? And that would be a no. So this is not a solution. If 5, 1 would have been located on the solid line, it would have counted as part of the shaded area, so it would be a solution.